Good day, students. How are you? Trust God, you are doing wonderful. Welcome you to Emmanuel's term, which is the first term. I welcome you to SS2. Wow, it's another great time again to learn. My name is Meshach Ojugo. I'm here to take you physics. First, before we go straight to our topic, I want to just give a little reminder. In SS1, you were taught distance. And I'm sure the definition of distance you learn is that distance is defined as a measure of separation between 2 points, or the gap between 2 points. So we'll come back to that. But I want to start with position. So our topic for today is position, distance, and displacement. Distance and displacement. We're going to be considering first the concept of distance. The concept of position. What is position? Position can be defined as the location of a body or point with respect to a reference point. Now, what do we mean by reference point? The reference point simply means a particular point that gives us the sense of direction to where the point is or the body. Now, the position of a point is a measure of the distance of the point with respect to the reference point. Now, what do I mean by that? Now, as I'm teaching right now, this board is located at a particular position. So, by the time you walked in and you were asked, where is the board located? You said it is located at a particular, with reference to something that is a part of where the board is. That is what we mean by reference point. So you begin from that. We call it the starting point. Now, what do I mean by that? Position can be described using the Cartesian coordinates. The Cartesian coordinates, we have three types of the Cartesian coordinates, or the coordinate system. The coordinate system is of three types. First, we have the Cartesian coordinates. The second one, we have the spherical coordinate. While the third one is called the cylindrical coordinates. The cylindrical coordinates. Now, among these three types of the coordinate system, we'll be considering the Cartesian coordinate system, which is the most commonly used coordinate system at this level. First, the Cartesian coordinate system consists of two or three axes. First, we'll consider the one of two axes. It consists of the Cartesian coordinate system consists of two or three axes. Now, for the two axes, we have the x-axis, which is the horizontal, while the other one is called the y-axis, which is called the vertical. Now, the x-axis is also called the abscissa in mathematics, abscissa. While the vertical axis, which is called the y-axis, is called the ordinate. So now let's put down the diagram of the Cartesian coordinate system. This is the vertical axis, which is called the y-axis, while the horizontal axis is called the x-axis, which is called the ordinate as well. Now we have the y-axis. Now we talked about the location of a point in space with respect to what? A reference point. Now in the coordinate system, where the two lines meet or where they join is called the origin. This is called the origin. The origin is where we mean by the starting point, where we start counting from. Now, the coordinate system, we normally put our origin as 0, 0. Now, if we want to calibrate this system, the coordinate system, we calibrate the x-axis. This is the positive direction. We have the positive axis. We have the negative axis. This is the positive axis, which is the x-axis, and also called the horizontal axis. While we have the positive axis for y, and we also have the negative axis for what? For y. So if I'm going to write or calibrate means to number the axis so that it can be read. So we have 1, we have 2, 3, 4, 5, 6, so on and so forth. So here we have -1, -2, -3, then -4. Then we also have 1, we have 2, we have 3, we have 4, we have 5, then we have 6. Then for the negative y-axis, we have -1, -2, -3, then -4. Now let's take an example to further portray on the coordinate system, which is, we're taking the Cartesian coordinate system now. Example 1. Locate the point P, we have -2 and 3, and Q we have -1 and 1 on the Cartesian plane. Already we have our Cartesian plane before us. So the first thing is to draw either the x-axis or the y-axis. Thereafter, we number the axis. We number the x-axis, which is the positive direction, the negative direction, and the positive of y and the negative of y. Based on the quantities given to us, we have P. P is -2. This is 1 point and 3. Then the next one is Q, which is -1 and 1. Simply, the first number you are seeing in the first point, which is number P, the first number here is on the x-axis. So we have the second one will be on the y-axis. These are the two values inside the first point. While the second point, the same thing applies. The first number we have here goes to the x-axis, while the second number goes to the what? The y-axis. Now let's locate the first point, which has the coordinate of -2 and 3. So -2 goes to x-axis. So I will go to where -2 is on the x-axis, and y is 3. This is positive of y, which is 3. So I will trace it to where I have 3 like this. I'm sure you are following me. Thank you, and God bless you. So this is -2 and 3, which is this point. So the next thing I'm going to do is to locate the point P, then bring in the coordinate. We have -2 and 3. So we have successfully located the point with the coordinate of -2 and 3. Then the next one is point Q, which has the coordinate -1 and 1. -1 goes to the x-axis as well. So I'm going to trace to where we have -1 and 1 on the y-axis. So I'm coming here. You can see how I'm tracing both -1 for x-axis and 1 for y. This is the 1 for y. So this point gives us point Q, which is minus 1. Minus 1 is the x-axis, while 1 goes to the what? To the y-axis. So let's take another examples for further understanding. Example 2. Locate the point S minus 3 minus 4 and 1 and minus 4 on the Cartesian plane. On the Cartesian plane. Now, the first thing to do in locating points on the Cartesian plane is to draw the axis. Now, the reason why we are taking 2 coordinates, because we have 2 values here. This is for 2 coordinate system. So we have to draw our vertical axis, which is the y-axis. Then the horizontal axis, please do not forget to indicate our origin. Yes. Then the next thing is to bring out our point. The first we have is minus 3 and minus 4. The second point is t. Let's put t there, which is 1 and minus 4. Now, the next thing is to calibrate our axis. Calibrate means start from the smallest number on the x-axis for the positive value. Since we have negative values on both points, we can also write on the negative axis. On the ground where the coordinates do not have any negative values, then we can only write on the positive of x and the positive of y. But from the 2 points we have here, you see this first one is our x-axis. The first value here goes to x-axis, and we have minus 3 here. Then the second value goes to what? Y-axis. The same thing applies to the second point. We have the x-axis here, which is the positive, which is 1. Y for the y-axis is minus 4. So it goes to the negative aspect of the y-axis. So let's calibrate our axis now. For the positive, we have 1, 2, 3, 4. Now looking at x positive, the least or the highest is just 1. So we can stop at 4. So we put x here, we put y here. Then for x negative, we have minus 1, minus 2, minus 3, minus 4, then minus 5. Then let's go to the negative of y-axis. So we have minus 1, minus 2, minus 3, minus 4. So we have, okay, we can get to minus 5. No problem about that. Now the next one is for the positive of y-axis. So we can have 1, we have 2, we have 3, we have 4, we have 5. Now we can conveniently locate our point. Now for the first point, we have the coordinates of minus 3 and minus 4. Now minus 3 is on x-axis. So this is x. This is minus 3 of x. So you trace it down to where you have minus 4 for y. So I'll just trace along the line downward. Then this gives me minus 4. So I'm going to locate the point here now, which is x. We have minus 3, which is x-axis, and minus 4. So the point x has been located. Then the next one is t. We have 1, which is positive for y-axis, and minus, 1, which is positive for x-axis, and minus 4 for y-axis. This is 1 of x. So I'm going to trace it down to the negative of y. So I have come down, 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 down here. Then I join the 2 lines together. So we have t. Now 1 is x-axis. Then we have minus 4. So we put minus 4 here. So we have been able to locate these 2 points on the Cartesian coordinates. Now let's go to the 3 coordinate system. The 3 coordinate system we have the vertical axis, which is the y. Then the horizontal, this is called the x. Then the third axis that looks slant is called the z. So this we have for three coordinate systems. So we can have something like x, y, and z. So we have x, y, z. So for this is for three coordinate system. You can see here the possibility of having a negative value cannot play out here because we only have another axis attached to the two axes which we know before. So in locating point, for example, let's take example 1 now to locate point on this axis. So we have locate the point Q with the coordinates 3, 2, and 4 on the plane or on the Cartesian plane. On the Cartesian plane. So you can see that we have three numbers. This is for three coordinate systems. So the first we have 3, which goes to the x-axis. Then we have 2, which goes to the y-axis. Then we have 4, which goes to the z-axis. So we can also calibrate our coordinate system. So we have 1, we can have 2, 3, 4. Then we also have 1, 2, 3, 4, and 5. So we have for z now, we have 1, 2, 3, 4, then 5. Now, the first value here, which is x, so we trace 3 to meet 2 on the y-axis like this. So you trace here to meet 2. Then the next one is the z-axis. So we move straight to where we have 4 on the z-axis. So let's take this off so that we can see clearly. So I have something like this. So we come here to join the 3 points together. So this is for the 3 coordinate system. Next, we're going straight to the next term, which is called distance. The word distance. Now, what is distance? Distance can be defined as the gap between 2 points. Now, from where I am standing to the edge of this board is a distance. So the point at that point and where I'm standing is a gap also. So a measure of separation between 2 points is called distance, or the gap between 2 points. And remember, in SS1, the unit of distance is meters. And not only that, we said distance is a particular quantity which we call is a scalar quantity. We have vector and scalar. And we said a scalar quantity is a quantity that has only magnitude but no direction. So distance is an example of what? A scalar word quantity. The next one is displacement. Displacement. Now, what is displacement? Displacement can be defined as the distance traveled in a specified direction or the distance covered in a given direction. That is the definition of displacement. Displacement, for example, if you are asked to do something and you said, "Mommy, I'm coming." When you say you are coming and you leave that particular spot, it means you have covered a certain distance to a certain location. But when you say, "Mommy, I'm coming, let me use the restroom." Now, if mommy or anybody comes in and say, "Where is Peter? Where is John?" He said, "John is in the restroom." That means John actually went to a known direction or a given direction. That is displacement. But if you say, "Mommy, I'm coming," you can go out of the house or go out of the compound, but nobody knows your whereabouts. That is, you have covered a certain distance. but where you are heading to is known. That means the direction is given by you. So we call that as displacement. That displacement is the distance covered in a given direction. And displacement has the same unit as distance, which is also meter, but not the same quantity as distance. The reason is because displacement is a vector quantity. What do I mean by vector quantity again? A vector quantity is one which has both magnitude and what? Direction. Now, I'm sure you'll be interested to know what's the difference between magnitude and direction. Magnitude is the size or the size of a quantity, while direction is the part covered by what? An object. So now, how do we determine the displacement of a given body? Now, the displacement of a given body can be determined using the relation. We have d x2 minus x1 all squared plus y2 minus y1 all squared. Now, these are the axes which we have talked about in the coordinate system, which are also used to determine the distance of a body from one point to another. Also, we can also have this is called for two coordinate system, which is the x and y. We can also determine the distance of the body in terms of the three coordinate system. We have d equals to the square root of, we have s2 minus x1 all square plus y2 minus y1 all square. Then we also have plus z2 minus z1 all square. So this is for three coordinate system. Usually we normally write, if I write p, I have x and y. This is two coordinate system. For three coordinate system using the letter p, we also have x, y, and z. So this is for three coordinate system, and this is the relation to determine the distance between the points. While for two coordinate system, we can use this to determine the distance between the 2 points. Now let's take an example. Calculate the distance between the points. We have A minus 6, 4, and B, we have 4. We have 4 and minus 4. Now, this is for two coordinate system. So we use our relation or our formula as square root x2 minus x1, then plus y2 minus y1 all squared. The first thing to do here, bring out the points. We have point A, we have minus 6 and 4. While point B, we have 4 and minus 4. Now, in this case, it's not the same way we normally represent them in the Cartesian coordinate system. We have 2 points. Here, the first one is called the first point. The coordinates we have, the values inside this first point, A, is 10 x1 and y1. So you can put it on top. While the second one is s2 and y2. So the first number represents x1 in the first point. Take note. While the second number in the first point represents y1. While the first number in the second point represents s2. While the second number in the second point represents what? y2. So we just replace these letters with the numbers. So we have d equals to first s2, we have 4. While s1, we have minus. So we have minus 6 all squared. Then plus we have y2. y2, we have minus 4. So we put minus 4 here, minus, what is y1? y1 is 4. So we also have 4 here, all squared. Thereafter, mathematically, minus minus gives us plus. So we have 4 plus 6 all squared plus minus 4 gives us minus 8 all squared. So if we square, okay, let's add up 4 minus minus 6, which is 4 plus 6. Here will be 10. So 10, we have 10 squared. 10 squared gives us 100. Minus 8 times minus 8 gives us plus 64. So we can leave our answer 100 plus 64. We can have 164. So we can leave it in terms of units, or it can be broken down in further way. The next we are going into is the frame of reference. But before we go straight to the frame of reference, we want to distinguish between distance and displacement. What is the difference between distance and displacement? So the first we have, this is displacement. Distance is speed, correct? Speed times time. This is one of the difference, because speed is distance over time, while displacement, which is also D, is velocity times what? Time. Another difference is distance, it is always positive, while displacement, it can be positive, it's positive, negative, or zero. Then thirdly, distance, it is a scalar quantity. We've said that before. It's a scalar quantity, while displacement, it is a vector quantity. So these are the few differences between distance and displacement. So thereafter, we go straight to the frame of reference. The frame of reference. Now, like we said previously, that the frame of reference, we have something of this nature. Now, we said for this, we can so the next we are going into is the frame of reference. The frame of reference. Now, the frame of reference, we normally use the three axes. We have the X, then we have the Z. So now, these 3 points, which is Y, X, and Z, have a common origin, which is termed as the position or the location where we have the place of rest. Now, on the earth, when we talk about the frame of reference of the earth, we refer to the inertia. Inertia simply means the state of rest. That is, anything can begin at that point. So, talking about the frame of reference with respect to location of points on a Cartesian plane, we say that the z-axis is normally drawn such that the x-axis and the y-axis are all from a particular point. That is the origin, their starting point, where we can trace or define each quantity with respect to the coordinate system as taught in our previous class. So I want to thank you for listening, and I pray that God will give you a better understanding as you study. Shall be 10 times better than your equals in all areas of your life. Thank you, and God bless you. See you some other time. Bye.